We are stepping into the next chapter, inverse trigonometric functions. Let us see. The concept of inverse trigonometric functions, actually you see the heading inverse trigonometric functions. In the last chapter, relations and functions, last session was about inverse of a function. A function to possess an inverse, it should be bijective. So when we say inverse trigonometric function, all the trigonometric functions should be bijective. So we will check the bijectivity of trigonometric functions later. Let us see the concept in a very simple way. Let us consider sine theta is equal to x. When we say sine theta equal to x, we can divide it into three parts. First part is trigonometric function, which is sine, the trigonometric ratio, right? Second part is that angle associated with trigonometric function, that is theta. And the third one is when a trigonometric ratio along with an angle gives a value which is a real value. Therefore, when we say sine theta is equal to x, we can consider three parts: trigonometric function, angle, and real value, so that an angle along with a trigonometric function gives a real value. Then the definition, very simple manner you can consider, then we can write theta is equal to sine inverse x. Theta is equal to sine inverse x. That means inverse trigonometric function along with x. What was x? Real value. So inverse trigonometric function along with a real value gives an angle. So up till time what we find is a trigonometric function and an angle. We always find a value. Here an inverse trigonometric function along with a real value will be given. What we want to find is the corresponding angle. Note that, very important note that sine inverse x is not equal to sine x to the power of minus 1. Because for sine square x, actually sine square x represents sine x the whole square. But sine inverse x is not equal to sine x power minus 1, because the right side, sine x power minus 1 represents 1 by sine x, which is cosec x. So don't get misunderstood that sine inverse x is sine x power minus 1. They are not equal. Some direct results. You have the properties of inverse trigonometric function. All the 6 inverse trigonometric functions are typed into 2 clubs. The first club is sine inverse of minus x, means inverse trigonometric function for a negative real value. Sine inverse minus x, cosec inverse minus x, tan inverse minus x. Here the minus sign, negative sign comes out of the bracket, which results to minus sine inverse x. Cosec inverse of minus x is minus cosec inverse x. Tan inverse of minus x is minus tan inverse x. On the other hand, the next club is cos inverse minus x, sec inverse minus x, and cot inverse of minus x. In this case, they represents cos inverse minus x is pi minus cos inverse x, sec inverse of minus x is pi minus sec inverse x, and cot inverse minus x is pi minus cot inverse x. So you see the difference between the two clubs, the two groups: sine inverse, cosec inverse, tan inverse of negative real value. Simply take out the negative side. But in case of cos inverse, sec inverse, and cot inverse of negative real values, they results to pi minus corresponding inverse trigonometric values. Now let us go how this happens. One of the proof from the first club, you consider sine inverse of minus x is equal to theta. Inverse of a trigonometric function, you are getting an angle. Let us consider it as equation number 1. Now you take sine to the next side. That means minus x becomes sine inverse, moving to the next side becomes sine theta. So minus x is sine theta. Multiply by minus sine, x is equal to minus sine theta. That means x is equal to sine of minus theta. In last year, we saw that sine of minus theta is minus sine theta. Now x is equal to sine of minus theta. Again, take sine to left side becomes sine inverse x is equal to minus theta. Multiply by negative sign, minus sine inverse x is equal to theta. Consider as equation number 2. Now you look at equation 1 and equation 2. Both the equations right side, RHS is theta. Therefore, left sides should be equal. What happens then? From those two equations, sine inverse of minus x is equal to minus sine inverse x. The same way, you can prove cosec inverse of minus x and tan inverse of minus x. Let us move to one of the proof from next club. You consider cos inverse of minus x equal to theta, equation number 1. The very same way, we are shifting cos inverse to the next side, becomes minus x is equal to cos theta. This implies x is equal to minus cos theta. Now you concentrate to the right side. What minus cos theta is? You know, cos theta is negative in second quadrant. In first quadrant, all the trigonometric functions were positive. Therefore, minus cos theta in second quadrant can be rewritten as cos of pi minus theta. This is the point to remember. Pi minus theta is an angle in second quadrant. Therefore, cos of pi minus theta is same as minus cos theta. That means x becomes cos of pi minus theta. Shifting cos to left side, cos inverse of x is pi minus theta. Shifting cos inverse to right side, theta to left side, you will get pi minus cos inverse x is theta. Equation number 2. Look at equation number 1 and equation number 2 with equal RHS. Right sides as theta, comparing left sides, we are here cos inverse of minus x is pi minus cos inverse x. The very same way, we can prove that sec inverse minus x is pi minus sec inverse x and cot inverse minus x is pi minus cot inverse x. Let us go for some examples. See, sine inverse of half. You think that inverse trigonometric function with a real value results in an angle. Sine inverse 1 by 2. How will you think? You think that for the value 1 by 2, what is the corresponding angle for sine? We know sine pi by 6 is 1 by 2. Therefore, sine inverse 1 by 2 is pi by 6, 30 degree. Consider a negative real value, sine inverse of minus 1. Just we saw sine inverse of minus x is minus sine inverse x. Therefore, sine inverse minus 1 can be written as minus sine inverse 1. Now, minus is there. What remains is sine inverse 1. For which angle the value of sine is 1? Very good. For pi by 2. Therefore, the answer is minus pi by 2. See next one. Cos inverse of 1 by root 2. Direct positive real value is taken along with cos inverse. For which angle 1 by root 2 is the value of cos? Very good. Cos pi by 4 is 1 by root 2. Therefore, cos inverse 1 by root 2 is pi by 4. Let us have a negative value in the second club. Sec inverse minus 2 by root 3. Sec inverse minus 2 by root 3. When you remember the formula, sec inverse of minus x is pi minus sec inverse x. Therefore, sec inverse minus 2 by root 2 is 2 by root 3 is pi minus sec inverse 2 by root 3. That is pi minus, what is the angle for sec? For the value 2 by root 3, it is 30 degree or pi by 6. Therefore, this results to pi minus pi by 6, which is 5 pi by 6. In this way, you can solve all the problems very easily.